In this video, we present a sketch interface for generating plausible motions using a modified motion graph technique as a backend. Our input is a database of motion files in ASF format drawn from the CMU database. Using the CMU annotations as a guide, we only load motions that are described as either walking, running, or gymnastic actions. Once loaded in, we divide these motions into smaller motion fragments of equal length. Using a weighted sum of joint angle differences as our distance metric, we create a graph of motion fragments and valid transitions by linking any two fragments that are sufficiently similar. We visualize this dense graph for the user. Here is a random walk of our resulting motion fragment graph. We align the roots of two concurrent motion fragments and perform some basic interpolation to create plausible but relatively seamless transitions. Now that we've created a graph of motion fragments, we can begin creating paths. The user places control points of an interpolating spline and then generates a path for a motion to follow. If the user doesn't like the resulting path, they can edit the spline on the fly. The user can employ what we call motion brushing to specify the desired motion types along the path. Currently, we support three motion types: walking, running, and gymnastic actions. The user selects the motion brush to apply and can then splatter the selected motion along the spline. This annotation is represented as a preference weighting, which is linearly interpolated in terms of the distance along the spline. Now we can generate a motion. We use a modified A-star search algorithm to create a list of fragments that, when combined, will roughly follow the selected spline, using a reward function to determine which fragment to examine next. This function rewards fidelity to the exact spline, progress in terms of distance along the spine, and fidelity to the motion type annotations. The more varied the motions in our database, the better the resulting motion. Here we have the resulting motions after trying to fit two paths. Currently, our database only contains motions that go in a straight line. Notice how the second motion cannot follow the turn and instead continues to go straight. Here, we see the result after adding veering right and left motions to our database. Notice how the motions fit better. Here are some sample motion paths generated by our algorithm. Even with relatively few fragments, we can generate plausible motions that are reasonably faithful to the user's specified path. Our system has trouble when the splines have turns that are sharper than we can handle with our current stock of options. Tuning the heuristic for A-star is data dependent. With the wrong parameters, it is very difficult to generate high fidelity motions since we either undervalue or overvalue distance from the spline. Our system allows even novice users to quickly author elaborate but still plausible looking motions. Thank you for watching.